Hello everyone, and today's topic is electronics product end of life and waste management. Electronic product waste is of course unavoidable. If we use electronics, we're going to produce some kind of waste. So today we will cover in the lecture the e-waste management, the waste, what it is itself, and also what kind of challenges we have in reducing the amount of waste we have, in the legislation, how to adapt it in the times when the times are changing as well, and we'll see some methods, how they can be, all the steps and how they are repaired, what are the challenges there, how they can be reused and recovered. In Europe, we use the term waste electrical and electronic equipment, or short I'll call it the WEEE. Sometimes it's called e-waste, but so in Europe the WEEE is more common also in documentations. And the electronic waste is a growing waste stream, and in 2019 the e-waste made around 53 million tons of e-waste was produced. So that's globally. Globally, the average per person, so one person, how much e-waste it produces is around 7.3 kilograms. So it's not very much, but like it's more than a regular household small kind of appliance. It's usually lighter. So we, of course, in Europe and also globally, we have a big variations of countries from country to country, and that even shows in Europe and USA the average is 13 to 16 kilograms, so double the global average, and that's why in these regions and also in Europe we have such a big focus on the electronic waste. But the trend overall also globally is that the e-waste amount is increasing, and it's increasing very rapidly. And it's projected that by 2045 the amount of e-waste is going to double. So this is concerning not only from the point of view that we have a lot of products on the market which are going to be thrown out, so a lot of waste, but also that the production of electronics require a lot of resources, and also a lot of critical resources, which in case of Europe, for example, the resources are not coming from Europe itself. We are producing electronics as well as importing, of course, but the resources for this production, almost all of it, comes out from Europe. So Europe has this challenge, but also an opportunity, what to do with the e-waste. And to combat this, or to somehow make it an opportunity, we have a WEEE directive. So WEEE directive sets the target for collection, it sets a target for processing the waste, and so if we know how much we have collected and processed, we know how much, what is the part we haven't collected. So we know how big is still the problem, because we know how much product we put on the market. And if we can, we have these balances all documented, we can evaluate how's the progress going. And such as in the previous, we had looked at the energy efficiency directives and the frameworks. We saw that, of course, the member states of the EU has responsibilities, and also, of course, here as well, the member states are responsible for organizing the national legislation. In the end, it's more or less the company's responsibilities, and that's why the extended producers' responsibilities are used to make companies involved in this process. They put products in the market, so they're also responsible how the product after the end of life is gathered and collected and treated or repaired or processed correctly. WEEE directive was set in force in 2012. There has been amendments later, and the main focus is the preventing of creation of electronic waste as itself. So if we can prevent creation of the e-waste, we don't have to invest in looking for solutions down the road. So the first priority is to avoid it itself. So how can we avoid it? Of course, we can try to prolong the lifetime of the product. We saw that it comes into play also on energy efficiency. It comes into play using these eco-design principles in designing the products. So they all come into play. Prolong this period, the product doesn't become waste. Another focus is assisting the reuse, recycling, and other forms of recovery. So reuse means that probably the equipment is either somehow needs to be, cleaned, maybe something needs to be repaired. So it's the process of deciding. There's a lot of options and questions: who is doing repair, who's doing the cleaning. Do we give more information about how to repair to the consumers themselves? Do we organize the specific trained institutions or companies who do these repairs? In that case, we keep some of the information only for specific companies or these organizations who repair, and so that can come with the positives or negatives. We'll discuss also a bit later. Another reason for directive is that the environmental performance is, of course, the bigger goal of all these directives, and electronics contain materials which are toxic, which can be hazardous and also be dangerous for health. So, of course, reducing amount of waste itself, having it better controlled. In all of these cases, it makes sure that human health is taken into account. Another point is that right now, as I said, in globally we don't collect all of the e-waste, and also in Europe we don't collect all of the e-waste. So where goes the rest of the waste which is not collected here? And the problem is that it often is illegally exported to some other countries. So maybe from the high-income countries are exporting the problem of e-waste to lower-income countries. And in those countries there can be a problem of not having well-organized organizations or systems to treat this e-waste, to repair and everything in a way that the workers' safety, the environmental aspects are all taken into account. Then lastly, I point out here that the directive helps to harmonize the electronic and electrical equipment registration and reporting. That's a big problem in global scope, because we have all different ways how we classify things, and if we classify them differently, in that case you cannot compare. Let's say one country says they produced X amount of small appliances, but in other country the small appliances mean one thing, and in another country it means something else. So if you see the numbers doesn't match from the exported and imported, that's because the classifications doesn't match. So directive tries to use, it uses some international systems of classification, but then again we will see it adapts more for Europe to make it. We always need to remember this burden, administrative burden, needs to be kept low. So in this case we'll see there's less categories than maybe globally used. Looking at still at the global scale, electronic products itself, they're very connected with economic development. So we know if the country's GDP per person are increasing, we know that we have more disposable income, we buy more equipment, we can afford to change the equipment more often, especially sometimes the functionalities are not lost completely, but we have the income to update. Why not do it? We have all kind of these systems where if we don't buy it fully, but we kind of pay every month money, so we don't own the product itself, we're kind of paying for the service of having equipment. And then on these systems, it's even promoted that you switch to a newer version and you keep paying the same kind of money or a bit different. But this creates the problem that maybe the existing product is still usable, it still hasn't lost the functions, but we are switching to a newer one because that's kind of the what the market is saying, that this is now nice and new options. And then we also have looking at the amounts of waste created, we can see that the collection of the e-waste is required by circular economy. So we mentioned circular economy before, that it's how we ensure that if the products come to the market, after the end of life, it's not disposed or shipped outside. But if the Europe is trying to make the circular loop within the EU, we're going to try to keep the equipment and the materials used in the producing of equipment in the EU. And we know that these materials contain the same material which is needed to produce the new electronics. So yeah, the main idea is to somehow enforce the circularity also of course the e-waste. In 2019, globally around 17% of the e-waste was properly collected. So it means 83% were not properly collected. What does it mean properly? It means that either there are in countries, depending on the country, if even does it have it, they have some kind of places where you can bring your equipment, or the equipment is maybe sold to some other countries by the consumers themselves. In that case, they are not documented. But if it's brought to the places where they collect it, like some national programs or something, then we can document it, and then we know that it can be recycled, and we know the fate. But as we can see, for now, globally, it's still a very big problem. It's very uncertain what happens with this waste, so it's far from circularity. In high-income countries, around 8% of smaller e-waste is also discarded in the bins. So, depending on a country, depending on a region, the waste, which is like the general waste, the household waste, it can be in some places it can be afterwards separated out, but in some cases maybe it's maybe incinerated, or in that cases it's lost, loses the option even to be reused in a circular way. And of course it more happens with a smaller equipment which is not as big. Again, but if it's a bigger equipment, then usually it's treated more properly, because often you cannot throw it out yourself. You sometimes call specific companies who come to your house, pick it up, then they take it somewhere else, and hopefully they treat it as and document it as it's required by some kind of national regulations. And I already mentioned that we have, of course, the problem with exporting and shipping the waste from high-income to low-income countries. The problem, what can happen, as I mentioned also before, is that there's a potential harm that putting these the products in another countries which doesn't have developed systems can create these. If you look from the previous lecture, we had these social LCAs. So in this case as well, we could see that we have countries where we have seen that one of the method how they treat the e-waste. They have these informal kind of shops, and they break up all the equipment, but there often is some kind of plastics involved, but maybe plastics are less valuable than some of the metals. So what they do, they burn it in the open pits, just so the plastics and all the other maybe fabrics or paper or something is burned off, and we're left with the metals. And of course, in that case, all the emissions goes to the air atmosphere. So we have impact on the local region for the human health, but of course also for the global emissions. Regulatory advances in some regions are slower, in some regions are faster. Europe, of course, is again trying to be a region who strides towards more circular economy. Of course, there are reasons for it, the reasons why Europe has become the place for this. We're not discussing that today, but the Europe has responsibilities for why it become richer and why it become higher income and so on. They have responsibilities for places that were often treated incorrectly, or so that's why, of course, now it's a good time that all the kind of good practices from Europe can be used in other countries. We have seen this also before, and that for example, the energy requirements, energy efficiency, like also the labels, they were developed in Europe, but they have been now used in other countries, and so the good practices are taking over, and all the countries can see the benefits by enforcing more regulations. But of course, the main reasons also for dealing with the e-waste are the toxic substances. We have mercury, and we have the flame retardants, we have CFCs, and also other possible substances which are harmful to environment and health, and that's why they have to be treated properly. And these substances, so they're hazardous, and there are looking at the in the globally in the undocumented waste stream, knowing how much it's produced, we can know that there are tons of these substances going into the environment, and that's why we need to make these documentation and regulation globally, not just in Europe. Another aspect we will look at is that the electronic waste is a mine, like an urban mine for raw materials. It was calculated that by knowing how much e-waste we had in 2019, that this e-waste, the materials that can be extracted from the e-waste was valued at $57 billion. So we know that there's a lot of materials which can be recovered, which can be used, but we'll see that some of the recovery rates are not that high, so still technological advancements are needed. So this is the elemental table, and it shows which kind of elements are found in e-waste, and we can see that this electronics are very complex. We have up to 69 elements from periodic table can be found in electronics, including such a precious metals as gold, silver, copper, platinum, and other ones. But there also are those called as a critical raw materials. So critical raw materials are ones which are either mined in very few places, and often the thing is that we sometimes say we have these rare earth elements. It doesn't mean they are rare per se, but that they at this point are economically available or mined in only few places. They could be abundant, but economically right now they're not mined because it's expensive, and that's of course again creates another risk. If it's hard to get this material, so it means in some places where the safety requirements for health, for environment are lower, of course it's cheaper because the workers and the safety requirements are lower, and so it creates the risk for outside gathering of these materials. So if we can get it from the e-waste, we reduce this risk also on the countries where we import materials from. In the EU, the amount of electronic equipment reached 11 million tons in 2019. And if you look compared to the graph we have starting from 2011, so the increase is around 47%. However, the treated amount has grown by only 35%. So it still has grown, it's good, but the growth is smaller. But already the initial amount of collected amount is smaller compared to the one which is coming into the market. So we know that the market is not something you can, you cannot put 3 times the amount of products in the market every year and think that there's still place for them. Of course, if we put something in the market if you look at the long enough scale, we should have the same amount collected if everything is collected. So we know that the collection rates are still not optimal. As I mentioned, in globally it's around 17%. In Europe, depends on the countries, but it's more closer to maybe 40%. So the directive also set the goals for the collection. In the first goal was set for 2016. We had 45% collected. And the goal was to collect 45%. Only 3 countries met this target. And by 2019, we have a new goal of 65%, which are still not met by most of the countries. Some of the countries which have met the previous goal were Bulgaria, Croatia. If you look at this graph, we can see that some countries collect more compared to put on the market. So this is amount of kilograms per person in a country, how much they put on the market, how much they collect. We see that some countries put a lot more products on the market than others. So mentioned before, the 16 kilograms per inhabitant, that's like an average, but we see that it very changes depending on the income levels. So in this case, the countries which have less products on the market are kind of in a better place, because if they use the same collection methods, sometimes they can reach higher percentage. And that we can also see in this graph, that countries which have lower numbers for placement on the market, they also have a better percentage of collected. I mentioned that globally the aim is to make classification unified globally. So initial classification for Europe is based on one developed by United Nations. So United Nations had 54 categories, and that's like bigger categories, and then they have around 660 product types. So a lot of different types. We know that for regulation sometimes it's very beneficial when it comes to specific for energy efficiency, for example. But Europe has decided that they will have a smaller number of these groups, so it's easier to do the statistics kind of. And initially in Europe we had 10 groups, and but in 2018 it was reduced down to 6 groups. So the 6 groups we have first group are the temperature exchange equipment, which includes such as things as refrigerators, we have freezers, but also air conditioners and heat pumps. So equipment which either heats or cools and are in this category. Second group we have all kind of TVs, screens and monitors. Then on the third group we have lamps. Fourth group we have bigger equipment. So we have something like washing machines, stoves and other large equipment, but also, for example, large printing equipment and PV panels are in the same group. groups 5 and 6 are both smaller equipment, depending on either fifth group is more like small household equipment, on the sixth group is more like IT equipment. And this classification means is used based on what are the planned collection rates. As I mentioned before, sometimes if the equipment is bigger, the collection rates are higher by themselves because the products are bigger. They are from one point of view, they are easier to collect because they are collected by someone, not thrown out by the consumer itself. And from the second point of view, bigger products are good to have higher targets because they contain more materials, of course. And also such things as refrigerators and other things, they can contain substances which are harmful to the environment. But the smaller groups like 5 and 6, we can see that the targets are lower, and that's of course the problem of one thing, that they are being, we'll see by the end some of the challenges, that in some cases they are just not correctly collected and are maybe sometimes kept by the consumers and not, or thrown out incorrectly. The third group, the lamps, of course they cannot be reused. If it's burned out, it's damaged, you cannot repair it directly, but you can recycle it. You can still get materials out of it, and it also has quite a high recycling target. That's because if we buy products, usually the lamps, usually they break down. Either they have this planned life, which is usually 10 years or longer. But usually if they break down in the first maybe 2 years, and then they are covered by warranty. So the people will take it to the shop, hopefully, and then it goes into the documented stream. So we can have higher targets. Another electronic waste are batteries. The batteries are not included in this the V directive because they have a specific directive. So it's a batteries directive, and some of the aims for this directive is to minimize the amount of harmful substances such as cadmium and mercury, not only how it gets in the environment, but also to make batteries already initially when they're produced to contain less of these materials. So then other aims are to ensure that the management of waste again is correct, and then of course if there are negative impacts possible, to minimize them. We know that batteries are the role of batteries are increasing as well. Just like if equipment, any electronics are increasing, then of course amount of batteries will increase as well. So, and even more so, because we know that we start to have even more and more wireless options. We have all the developments of Wi-Fi's, new higher frequencies and so on. So it means more equipment will contain batteries, so we don't have to have it wired. And some other, we know that batteries also, of course, are important in electrification of the transportation sector. So that's a huge part of which is only coming now, and the recycling and recovering these materials will be very much the talking point for the next years as well. So that's why the global demand for the batteries are planned to increase maybe even 14-fold by 2030. So we saw that the E-stream is maybe projected to double by 2045, but batteries might be even going a lot, increasing in a lot higher numbers. And of course, batteries, they have a challenging end of life. It's not as easy to recover because they are chemical, and then if something goes wrong, and there's chemical reactions happening. So a lot of these materials have difficulty to be recovered and recycled. Looking at some statistics for batteries, then we know we often have seen the collection boxes for batteries, so we know it's big part of them are collected. This also shows up in the collection rates that in some countries such as Croatia we even have 101% of collection. That means that possibly they were either getting some batteries from somewhere else. But of course, most of the countries are more around, again, still around 45%. In many cases, it's a problem of batteries being kind of stored and not, even if they are old and like such, people, they're just small. If it's very small, people often don't bother taking them to the collection locations. Although comparing to 2012, the increase have been quite significant in the amounts. We can see the 2012 rates are those green boxes. Again, depending on the countries, some have for some reason or even decreased, maybe changed some classifications or something. But for the most countries, there was an increase. But looking at the collection rates like these blue bars, we see that years 2016, 2018, there hasn't been big difference. So it means that the existing kind of these options of having maybe the boxes in shops and so on maybe are not enough. So something else maybe needs to be added. Looking more broadly at all the e-waste, what do we want to have? What do we want the e-waste, how it's being processed? Of course, as I mentioned, the priority is that nothing becomes e-waste. But when it becomes something, we want to try to recover as much as possible. So the second best is to use some kind of recovery method, and those include reducing the amount of waste. So if you can repair something, preparation for reuse is important aspect. But for that we need a workforce, and we need someone who can do this repairing. And often of course, another problem what comes is that if consumerism is not regulated, the people, if they cannot afford, also that's the problem, then they will buy maybe cheaper alternatives, like an off-brand equipment, and in some cases it's a base decision why to do it. But there could be additional problems which probably consumers never think about it, because if the equipment is unbranded, it means there's usually no instructions and so on, and so that can be a problem. And then if reuse is not possible, then we have a possibility for, of course, again, recycling as much as possible. Then we need to be possible to separate, to take the equipment apart. So make sure that we have less gluing, less connection methods which are not easily separable. So we have all the plastics marked, so we can separate them in right waste streams. And if standardization is used, then we know how what are the elements marked, so we can desolder and separate them correctly as well. And when by the end, if it's not possible to recycle, then there can be some kind of recovery methods. Either those can be chemically, or maybe some physical recovery methods. But if it's not possible, then the last option is disposal. So looking at the e-waste management stream. Usually we have had this linear method where something is manufactured, then it's used, then there's end of life, then it goes to the waste. And again, looking at the circular approach, we need to have a new kind of steps added to this thinking to make it circular. So firstly, you have to have collection. Either it's in the stores, municipalities, companies, that in all of these places that the waste is separated in these 6 categories. So if it's in these 6 categories, we know that it's documented correctly, we can know the amounts, and then we can have specific targets for each of these groups. Then the second part is pretreatment. So we open up the equipment, we have maybe manual sorting, we have battery removals, and we can remove some kind of hazardous substances so it doesn't go into the next steps. After that, we remove the non-ferrous materials, and so metals are removed before. And then on the sorting, we have these plastics which come out from the shredding, and then if it's possible, we use some kind of methods to separate these plastics by their types. And then lastly, we create a new product or kind of resource material from these plastics, which can be used again in production of new products. Currently, it's usually in a low percentage. Some specific parts of the electronics doesn't have that high requirements, and there can be the percentage of recycled material and can be higher together with the virgin material. Looking at the reuse of equipment, we have some kind of obstacles for it, and we also have drivers. And some of the obstacles are for that if we have set up some kind of organizations which can do this preparation for reuse or repairing and so on, they need to have the spare parts, and also the logistics needs to be there. So we need to know that the manufacturer have produced these spare parts. That's why also these new legislations come and say that manufacturers are obligatory. If they sell something in Europe, they will have to have inventory of the spare parts. Then it can be additional cost for municipalities because they need to organize it somehow. The problem is also consumer perception, because we usually like to have stuff which is untouched by someone else before. That's a big challenge to have something used by someone else. But so if we can appreciate that we're not creating, if we put the other problems higher, then this issue can be overcome as well. And then, of course, as usual, we have legislative frameworks which need to be there. But some companies have also, so this comes from the discussions with the companies, and they have pointed out that it creates sometimes unfair competition because some of the organizations are not respecting all the quality standards, how the equipment needs to be repaired, and so they can do it cheaper, and it creates bad competition in this sector for repairs. But then there are drivers, so we need to have quality control, which ensures, again, there is no problem with this competitiveness. We need to have some kind of security standards, so it's safe. For some products, there could be requirements how to make it safe. We need to have open dialogue between manufacturers and reuse organizations. So manufacturers already in the design incorporated the aspects, so it's easier to reuse these things. And of course, commitments by all parties. This is one study done in Germany, looking at which products, what could be the impact on multiple categories, similarly like in LCAs. Also here we have so we have categories such as climate change, toxicity, resource scarcity, and water consumption and energy demand. And they compared all kind of equipment, if it's being bought new, or if it's being this PFR, if it's after the pretreatment of for reuse. And the study found that in most cases, if it's highly valuable equipments which are smaller and are not that energy intensive, then in most cases the percentage we see on the left for laptop, they all are positive. So it means that there are reduction in impact on environment and all the other categories. But on the right we have example for refrigerator, so the bigger equipment which sometimes use more energy, and we have had a higher increase in efficiency in last years. So in energy efficiency presentation we saw that some products have really increased in efficiency, and refrigerators are one of them. So we have newer technologies, and containing less harmful substances in them. So in this case, sometimes the reuse can have a negative impact. So it's not as straightforward that everything should be fixed. There should be some kind of more analysis of that before putting on the policy. One of the problems the companies are pointing out is that to reuse the equipment, there has to be traceability. So we know all these words as blockchain technologies and so on, somehow make a system where thing can be traceable throughout all of its life. So something like that is required, and also what companies say they need it, because one of the big sources of electronic equipment are big companies. Big companies sometimes decide, okay, we're going to update our inventory, so they have a lot of things to kind of donate, but they cannot donate it to someone just like that, because it's part of their budget stream. They need to report where their assets go. So if they can trace it, if they can for national institutions, they can show it where they went, so they can do it. And of course, the other thing is that we need to have to produce the quality second-hand products. So that's why all these standards and other things are required for reuse of electronics. I already shortly mentioned that repairability is a problem for non-brand equipment. So the one thing is we don't have the documentation. The other thing is that there are could be no spare parts even available, because how do you know where to look for the spare parts if there is no one manufactured it, and there's no identification of the parts and so on. So even if you bring it to someone to repair, that place is the official ones is going to say that they can't fix it. So the only option are the informal ways, and which are not always bad, but that's again everything happens outside of the documentation. So it's could be good, could be bad. No one knows. Then there are recovery options, which are for when we have the waste stream. We have kind of two main traditional methods, which is the hydrometallurgy and which is chemical type, and we have pyrometallurgy, which is more a thermal type. So development has been also in this sector, but the first two methods they are traditionally used, but they can have some kind of problems that they require a post-treatment. So after these methods are applied, we might have chemical solutions and gases which are toxic, so we need some kind of post-treatment. But there has been development of new biohydrometallurgy, which are kind of using some methods which are more versatile and environmentally friendly. And looking at these recovery methods previously mentioned, again, it depends what kind of materials we're trying to recover from. Because in electronics waste stream, you have a lot of also, for example, like wires coming in. So we might get more kind of copper. But if it's more electronics per se, then those could be categorized as high-grade waste. And here we can see that on the top we have palladium, gold, silver. And by the very last column, we see that the overall recovery is around maximum 25%. So we see that for the bottom four metals, which are more common ones, we have more amounts in the products, but the recovery methods can be a lot higher. But for the highly valuable ones, the recovery rates are still quite low. So there's still technology needs to advance, because of course we're losing 75% of the materials. So about the challenges, the companies are saying that we need maybe have limited repairability information, because it can be sometimes dangerous if consumers are given too much information and they try to do it themselves, but they're not trained to do it. And not just unsafe for themselves, but they might use too much materials to do it sometimes, and so they create bigger environmental impact than if they would buy a new one. So sometimes this limited repairability is necessary. And repair services need to be supported, so municipalities come into force, need to be more enforcing of the existing already rules. We need these traceability, maybe with the digital passports. And so how much information should be given out, it's similar to the first point, still needs to be discussed. And then there's a liability. So after it's repaired, if it's done quality, then we can probably prolong the guarantee. And there are also challenges from looking at the social aspects. So we can promote new jobs. So it's assumed that we might need to have up to 700,000 new jobs to repair all of these equipment. So, but again, if we repair something more, we're going to lose jobs in other sectors. For example, if we have more waste stream coming from recovery, we will have less need for resources, the raw resources. So in those sectors, the people might lose job. Maybe we will even sell less equipment. So even also in that part, we might lose jobs. So there are some social consequences needs to be considered. And similarly, environmental aspects need to be considered, that if more this treatment is used, then e-waste is not coming into the Europe because it's too regulated, and maybe it's going to go somewhere else and create problems there. So the consumers themselves are also a challenge, because what they say is not always what they do. And so this graph on the right is kind of saying that in some cases the consumers were asked what do they do with the e-waste, and although 76% claim that they sort their e-waste, then why only 35% of the e-waste is collected. So the claims are not always the action. And most of the people, although are aware of consumerism, what it is, but of course it's not that simple to just switch away from it. And people require some kind of swaying, and the consumers are a very important part of all of this life cycle. Some other studies have found what happens with all kind of different equipments. And we can see that for some things as laptops, the big problem is that they store, and also other smaller valuable equipment, they store it at home. So we hope that this product might be useful later, because if the new one breaks and so on, we don't put it back on the recycling. And what can happen is that the legislation changes. For example, we say that okay, these electronics cannot contain that much hazardous substance, but if this product for 10 years sits in a closet and only after 10 years goes in a waste stream, then this waste stream needs to be able to still deal with hazardous substances which were allowed 10 years ago. So it means that it's harder to advance also on the waste stream recovery methods. So to summary, we have a big e-waste global problem. It's growing and possibly will double in the next 20 plus years. Only around 20% of e-waste is properly collected, or even a bit less. In Europe, we have the V Directive, which tries to which sets up the targets, and countries are trying to reach these targets. And we have main 6 categories. We have some larger equipment which have higher targets. We have smaller equipment which have smaller also targets. And e-waste is a problem, but it's also a potential source for materials. It's a potential how Europe can become less reliant on outside materials. So it is an opportunity as well. But of course, it's a challenging challenges in management. So how do we ensure the repairs are quality? How we ensure that still maybe some social aspects as informal repairs. So we want people to be more social aware. We want to make maybe informal socially created repair shops where local people are trained and so on. But it comes again with a problem. How do we balance this safety and quality? And then, of course, we need to increase the waste quality itself by properly separating it, and and collecting it and documenting it and increasing the traceability. And lastly, it's how do we nudge consumers actually to do everything correctly. So in summary, we have the e-stream is going to be still a talking point in the next years. We have a lot of challenges, but it's a big potential for Europe to help also how socially it's impacted the other nations outside, because we're very reliant from the outside sourcing. So it's a topic which is going to be still talked in future. Thank you for listening to this lecture, and hope you had valuable information about the e-waste.